Hi students, welcome to exercise 10, lesson on trigonometric ratios. First, let's recall a little bit of information. Usually what we do is we identify theta as our arc length. So if you look at around the unit circle, the angle is the arc length around, and that's measured in radians, if you recall from exercise 9. We also have a point on that circle, in this case would maybe be the unit circle, is defined by point xy. So if I was to draw a triangle to describe that, I would have the triangle here, right, this right angle triangle. This would be our x value, this would be our y value, and this would be the point xy. And our angle here would be measured here. Again, that's the measured angle. The arc length would also be representing the angle in radians. If we use the trigonometric ratio SOHCAHTOA, which you learned in grade 10, we have sine equals to y over 1. So again, we're going to talk about specifically the unit circle, but it doesn't have to be the unit circle. If we do have the unit circle, the sine theta will be equals to y opposite over 1, which y over 1 is y. Cos is equal to x over 1, so cos value is x. And the tan ratio is opposite over adjacent, which is y over x. So the same thing as saying sine over cos, because if sine is y and cos is x, then you could just say y over x is sine over cos. Alright, so thus any point on the unit circle can be described as a point with the angle, is cos of the angle, comma sine of the angle. So this would be your x value, right? So this would be the same thing as saying any point x, y on the unit circle. So we're going to often refer to cos as the x value over here, and so it often be referred to as the x value, and sine will often be referred to as the y value on the unit circle. Okay, so maybe talk about the reciprocal functions quickly. So the primary functions are sine theta equals y, cos theta equals x, tan equals to y over x. So those were just described. There's new functions, reciprocal functions, which is 1 over f of x, or 1 over our original function. So cosecant is the function cosecant theta, which can also be written as 1 over sine. So this is the reciprocal of the sine function, and that would be 1 over y. Secant would be 1 over cos, which is 1 over x, and cotangent is 1 over tan, or x over y, or cos over sine. So it's basically just flipping this fraction, right? So it would be reciprocating this fraction, so it's 1 over tan, reciprocating that fraction, so it's x over y. So we did the same thing over here. So again, to remember, cosecant is the reciprocal of sine, secant is the reciprocal of cos. Alright, in this first example, we have a point 5 over 13, comma negative 12 over 13. So again, these are your x and y values, right? And this point lies on the terminal arm of an angle in standard position. Okay, so an angle in standard position, as we've seen before, is an angle, starting from the x-axis, and lies, if you look at it, the x is positive and the y is negative, so lies in the fourth quadrant. So we'd have a terminal arm here. This would be our point, right? And notice that you can draw a triangle, right angle triangle from that point. So the x value is 5 over 13. So this would be 5 over 13. And the y value, we're going to write it negative 12 over 13. We understand it's a distance, so it can't be necessarily negative, but we'll write it as negative because we're showing that y value is the negative in the fourth quadrant. So draw a diagram of this situation. So the point lies on the terminal arm of an angle in standard position. The angle that we're playing with here, which is often misunderstood here, the angle in standard position would be the angle all the way around starting from the x-axis. Okay? Now we're asking to find all 6 trigonometric ratios for that angle. Okay, so even though the angle is that full angle around, all we have to do is deal with this angle here, and this angle specifically there will let us find all trigonometric ratios. Okay, so we're going to call this the theta, Okay, and we're going to, it's technically a reference angle, right? We're going to identify all the values of sine and cos. So because this angle, this point is on the unit circle, our hypotenuse is 1. If you're not sure and you want to find out the hypotenuse, you could simply calculate the Pythagorean theorem, Pythagorean triangle, right? So it's negative 12 over 13 squared plus 5 over 13 squared, and this gives us 144 over 169 plus 25 over 169. Sorry, this should be equal to, I don't know, r squared equals to r squared. You have 1 equals to r squared, so then obviously this is equal to 1. All right, so let's identify all the values. So we have sine theta, we have to identify cos theta, tan theta. We also need to identify cosecant theta, which is the reciprocal of sine. We have to identify secant theta, which is reciprocal of cos, and cotan theta, which is the reciprocal of tan. So what we usually do to find these is we simply find these three primary trigonometric ratios first, and then we'll find the reciprocals after. Okay, so the sine theta, the sine is the opposite over the hypotenuse. Well, the hypotenuse is always going to be 1, so that's easy. So it'll just be the y value. So what we have is sine is negative 12 over 13. So again, notice that it corresponds to your y value of your point, right? Because it's on the unit circle. Well, the same thing will happen with cos. So cos is 5 over 13. All right, tan, you're going to have to do a little bit of work, possibly. It's the division of y by x. So if you divide y, negative 12 over 13, by x, 5 over 13, you're going to notice that the 13s are going to cancel out. So what you're going to have left is negative 12 over 5. All right, well, here, these are actually quite simple when you find these. It's just the reciprocal of these. So all you got to do is flip every single fraction, and you're going to come up with your solution. So here, negative 13 over 12. Notice I usually keep the negative at the top, or on the numerators, just to be consistent. And here this is 13 over 5, and over here you have negative 5 over 12. So that's fairly simple. All right, so in the second example here, if cos equals to 1/5 and theta is in the fourth quadrant, find all other 5 trigonometric ratios for theta. All right, so first thing I'm going to do is I'm going to draw out this angle. So this angle is in the fourth quadrant, right? So, and you have cos is equal to 1/5. So cos is your x value. So what we're going to do it slightly differently here. So I'm going to draw my right angle triangle in the fourth quadrant. And cos is always adjacent over hypotenuse, right? So if our angle is right here, adjacent would be 1 over hypotenuse, which is 5. So I've simply just taken this ratio over here as adjacent over hypotenuse. So angle, adjacent, hypotenuse. And this removes a little bit of the fractions we have to deal with. So now I can find the value of this side. We're going to call that y because it's vertical, right? We can easily find that angle, that side by using Pythagorean theorem. So we have 5 squared minus 1 squared is equal to y squared, right? Because I'm looking for the side that's not the hypotenuse. So here we have 24 equals to y squared, and you have the square root of 24 equals to y. Well, notice the y value is negative, right? Because we're in the fourth quadrant, so similar to the last example. The y value is negative here, so I'm going to write this as negative square root of 24 equals y. All right, so find all other 5 trigonometric ratios. Well, all other 5 trigonometric ratios, again, come directly from this. So I'm going to write them out here. So we have sine. We already have cos, but I'm going to write it down just to make sure we write them all down. So tan theta, and then I'm going to write all, the reciprocal ratios. Okay, so cos equals to 1/5. We got that one already. Sine is going to be equal to opposite, right? Opposite over hypotenuse. So our opposite side is this, so it's going to let us answer for sine. So it's going to be negative square root of 24 over 5. Notice that you can write negative square root of 24 as negative 2 root 6, but that's up to you as a preference. And tan is going to be opposite over adjacent. So opposite is negative square root of 24 over adjacent, so over 1, same thing as saying just negative square root of 24. And now, again, the reciprocal functions are just the reciprocals of those fractions. So I'm going to flip that fraction. I'm going to flip that one. 5 over 1 is 5. I'm going to flip this one, and there we have it. Alright students, so for this next example, I recommend you have your trusty little unit circle around so that way you can follow along. I will be using it and making reference to it. So I'll bring it out a couple times just to focus on it a little bit. So determine the exact values of the following trigonometric ratios. Well, what we learned in the first part is that the cos value is the x value of a certain angle. The sine value is the y value, and tan is y over x. And all the other ones that are reciprocals of the primary ones. So basically what I'm telling you is that you can get all these values that we've presented here, right? So all these values here just by using your trusty little unit circle. Okay, so the first one, very basic, the cos of pi over 3. Well, if you look closely at pi over 3, I'm going to bring this in. So pi over 3 is this angle right here, right? So pi over 3 would be this angle. And it gets us to this point. And there's a little reminder on this unit circle saying the x value is your cos theta, your y value is your sine theta. So therefore, at pi over 3, the angle is formed here, the x value is 1/2. So therefore, all I'd have to do is say cos of pi over 3 is simply 1/2. So again, that comes directly from this trusty little unit circle over here. Okay, so secant isn't on this unit circle, okay, but we learned that secant is the reciprocal of cos. So if you have the same angle, you're at the same spot. So all you do is take the reciprocal of that value, which is simply, in this case, 2 over 1. You don't have to write the 1, so you could just simply write 2. Alright, so simple enough, right? Okay, so now what if the angle isn't exactly one of the angles given? So for example here, this unit circle, all it really describes is all the values between 0 and 2 pi, right? Well, what happens if you have a negative angle? Well, that's where the coterminal angles come into play, which you've already learned. So instead of going positive 5 pi over 6, which is positive 5 pi over 6 is this, right? So again, 5 pi over 6 is here. So I'm going to go into the negative direction. So I'm going to start here and go into negative 5 pi over 6, which gets us into this exact spot. So that's basically the point we're talking about. So if we're talking about the sine value over here, you're talking about the y value at this point. And sorry, that's right here. So therefore, our answer to this question would be negative 1/2. So again, because this angle corresponds to this point, and the y value is negative 1/2. Alright, so I'm just going to move this so we can read it. So cos of 7 pi over 4, well 7 pi over 4 is an angle on our unit circle. So this is 7 pi over 4 over here. The x value, because we're talking about cos, right? So the x value would be square root of 2 over 2. So square root of 2 over 2. Alright, now we're talking about angles. So angles aren't radians, but kind of works the same way, right? So you find your 270 degrees, you go around, and your cotan, if you remember, and I'll just rewrite it just for reference, your cotan is x over y. Okay, so what you're doing is you're going to go look for your x and divide it by the y value. So if we look at our x value, we have x is equal to 0 over y, which is negative 1. So quite simply here, you have 0 over negative 1, which is the same thing as saying 0. So the cotan value, the reciprocal of tan, is 0 at 270. Okay, cosecant of 2 pi over 3. So again, you don't reciprocate the angle. It's not the angle that's going to become 3 pi over 2. All you're going to do is you're going to go to the 2 pi over 3, so you got to find this angle first. Okay, first thing to do, find the angle. So 2 pi over 3 is right here, so we're at this point. Okay, so this is the reciprocal of sine. So you take your sine value, which is your y, and you reciprocate that value. And it so happens that the reciprocal of square root of 3 over 2 is now, whoops, 2 over root 3. So it looks like our little root 2 over 2 is going to follow us around here. Not a big deal. Okay, and we're going to keep going down. All right, tan of 11 pi over 4 again, so this would be a coterminal angle situation. 11 pi over 4 is not here. So what we're going to do is we're going to find this angle in the first revolution. So the way we're going to do that is I'm going to take 11 pi over 4 and I'm going to subtract a revolution. So I'm going to subtract 8 pi over 4 because 8 pi over 4 corresponds to, I hope you remember this corresponds to, this corresponds to 2 pi. Okay, so this value corresponds to 2 pi. So therefore now we have 3 pi over 4. So this 11 pi over 4 over here, right here, is the same spot as 3 pi over 4. So that's the first thing we're going to do. We're going to find our 3 pi over 4. Our 3 pi over 4 is right here. So we're talking about this point, which means those are the coordinates we're dealing with. So tan of this value is y divided by x. So I'm going to write that down, and hopefully you see something that happens pretty quickly. Sorry, let's black it in. Square root of 2 over 2 divided by negative root 2 over 2. So notice that the numerator and the denominator are the exact same value, right? This is the same value as that. And anytime you divide something by itself, you'll always get 1. Notice we have a negative as well, so the answer becomes negative 1. Secant of 5 pi, so again, you're talking about a coterminal angle. So notice that 1 pi is this, and then 2 pi, 3 pi, 4 pi, 5 pi. So we're talking about this value right here. And the value of cos, because this is reciprocal of cos, is negative 1. So all we have to do is say, oh, okay, well this is 1 divided by negative 1, which is also negative 1. So they share the same value at that point. Okay, and we're just going to quickly read this note. It is easier to find the coterminal angle in the interval 0 to 2 pi, and then find the appropriate value according to the trig ratio, which is exactly what I did follow. Okay, so for this last example, I'm going to again use that unit circle. So notice that unit circles are along to the side here, so I can use it. We're going to determine the exact values of the following expressions. So basically, it's what we did in the last example, just putting a few of them together, right? So we're adding and subtracting values that we found. So cos of 120. So 120 is over here. Okay, so 120 is over here, which means cos is the x value. Right, so we have negative 1/2. So this is right here, negative 1/2. I'm going to put it in brackets so that way we don't mess up any negatives. So we have subtraction between the two. Tan of negative 135 degrees. So a negative 135. So notice that this is positive 135. Negative 135 would be the opposite direction. So you're at this point. And I hope you can recall that the tan value is division by y over x. Notice that they have exact same values. So this gives us 1. Positive 1 because they're both negative. So you have here 1. And then when you subtract them together, you get negative 3/2. And there's our value. Okay, so for the next one, you might remember what this value is. You have sine squared of an angle plus cos squared of an angle. If those two angles are the same, it should come up to a certain answer, and I'll talk about that at the end, after we find the answer. So sine of 7 pi over 6, well, 7 pi over 6, again, you got to find that angle. So 7 pi over 6 is the same angle for both. 7 pi over 6 is over here, so our sine value is here, and our cos value is here. And what I'm going to do is I'm going to insert them into the value. So notice that this squared here, this square is the same thing as saying square of all of that. So the sine of 7 pi over 6 is negative 1/2, and that square is saying we're squaring that whole thing. And the same thing is going to happen for cos. So cos is negative root 3 over 2, and we're squaring that whole thing again. Well, after I square them, I get 1/4, and then plus, here would be 3 over 4, and notice that gives us 1. Well, that's what I was trying to hint at earlier, is that anytime you have sine squared plus cos squared of the same angle, so that's the one of the first trigonometric identities that you found. It's found on the units on the on the unit circle, right? So x squared plus y squared equals 1. Anytime you take 2 points here and you square them, you're always going to get 1. And that's true for any of these points on a circle. Okay, next one. Cot of negative 3 pi over 4. So first again, find negative 3 pi over 4. That's over here. And cotan is your x over here. X divided by y. And notice that anytime you divide the same thing by itself, it's actually the exact same value as that. And you divide x by y, it still gives you exactly 1. So what we have here is 1 plus pi over 2. So we're going to go find pi over 2. So pi over 2 is over here, right, on your unit circle. And we're talking about the inverse of sine. So the sine value is 1. So when you reciprocate 1, you get 1 over 1. Well, notice that that's still 1. So you have 1 plus 1, which is 2. All right, last one. And this fairly long lesson. So negative pi over 3. So again, pi over 3 is like this over here. So negative pi over 3, we're going over here. So negative pi over 3, so you take the tan value of that, right? So tan is y over x. And now I'm going to write that whole thing down. We got some room here anyway. So y is negative root 3 over 2. So that's y divided by x, which is 1/2. And notice that the whole thing is squared, right? We have this squared here, over here somewhere. So this whole thing is squared. So this is y over x, and the whole thing is squared. And this is all multiplied. So there's a multiplication between these two functions. So there's a multiplication, so I'm going to use a little symbol of multiplication to show that. And then we have 4 pi over 3, secant. So again, 4 pi over 3. We're on the hunt for 4 pi over 3. You get right here, 4 pi over 3. And secant is the reciprocal of cos, which is the reciprocal of the x value. So what I'm going to do is I'm going to take that x value and flip it around. So instead of saying negative 1/2, I wrote negative 2 over 1. All right, so we've got a little bit of work to do here. Hopefully we don't, yeah, good, it doesn't drag with me here. We've got to simplify this expression before we actually square it. So notice that they have the same denominator. Anytime you divide a fraction by a fraction and they have the same denominator, you can just eliminate the denominator. So what we get is negative root 3 squared times, and I'm going to simplify that one on the right too, negative 2. So negative root 3 squared is actually 3, okay? Because you have this negative 1 squared, which is 1, and this root 3 squared, which gives us 3. And this is times negative 2. So times negative 2, which gives us negative 6. All right, and that's it for the lesson, guys. Hope you enjoyed it, and I'm sure we'll have some discussions in class.